Black holes have always been shrouded in mystery, appearing as enigmatic phenomena floating through the vast expanses of space. For centuries, humanity has looked to the skies and pondered the nature of these invisible giants, armed with only questions and very few answers. However, recent scientific advancements have allowed us to peer deeper into the mysteries of black holes than ever before, shedding light on what lies within these dark cosmic entities. In this detailed exploration, we'll delve into the latest groundbreaking discoveries scientists have made about black holes, revealing theories, startling discoveries, and the journey of research that led us here. The birth of black hole theory. Our understanding of black holes began in 1916, when Albert Einstein's general theory of relativity revolutionized modern physics. Einstein was the first to predict the existence of black holes, envisioning regions of space with such immense gravitational force that nothing, not even light, could escape them. However, the term black hole itself wasn't coined until 50 years later. Initially, Einstein's theory was met with skepticism. While some scientists saw merit in his predictions, many dismissed them as theoretical musings. This changed dramatically in the late 1960s with the discovery of Cygnus X1. While observing the Cygnus constellation, researchers identified an unusually bright blue star emitting X-rays. Further study revealed this star was orbiting an unseen, massive entity, a black hole. As researchers observed X-rays being pulled into this invisible mass, they confirmed the existence of black holes, shifting them from theoretical objects to real, observable phenomena. This single discovery opened the door to a cascade of new findings, leading scientists to believe there might be as many as 100 million black holes within the Milky Way galaxy alone. The properties and potential dangers of black holes. Understanding black holes involves more than just confirming their existence. Scientists have since aimed to determine their physical properties and behavior. According to physicists, black holes are regions where anything that crosses their boundary is compressed to an astronomical degree until it becomes a singularity, a point of infinite density. This means that if a person were to fall into a black hole, they would be stretched like spaghetti due to the immense gravitational pull. Though the closest known black hole to Earth is around 1,500 light-years away, this information leads us to an alarming question: could black holes ever threaten Earth? Despite this concern, scientists believe such a possibility is minimal given the vast distances between us and known black holes. In 2021, researchers captured the first clear image of a black hole, located in galaxy M87, which added a new dimension to our understanding. This black hole was photographed repeatedly over several nights, and these images revealed surprising details about its structure. Unlike the simplistic idea of a single, dark void, black holes appear to have multiple layers. At their outer boundary lies the event horizon, a point of no return where the gravitational pull is so intense that not even light can escape. Within the event horizon lies an even deeper layer, ultimately leading to the singularity. The event horizon's powerful gravity prevents anything from leaving once it has crossed this boundary, meaning that to escape a black hole, an object would need to travel faster than the speed of light, a feat currently deemed impossible. The black hole's singularity and the anomalies of physics. The singularity at the core of a black hole holds most of its mass, and the laws of physics as we know them break down in this region. Unlike the more predictable behavior of stars and planets, each black hole has a unique gravitational pull, meaning that what applies to one black hole might not necessarily apply to another. This variance adds a layer of complexity for scientists who study black holes, as each discovery often raises more questions than answers. Studying black holes directly is an immense challenge. Researchers rely on analyzing the radiation, dust, and gas surrounding black holes since sending a probe would be futile. It would be crushed upon reaching the singularity. Theories and speculations. What could lie beyond the singularity? Given the limitations of direct observation, scientists have proposed several theories about what might exist within or beyond a black hole. One of the most popular theories is that black holes might act as portals or gateways between different galaxies or even universes. Inspired by the movie Interstellar, this idea suggests that beyond the event horizon and singularity, there could be a wormhole, an intergalactic shortcut that might enable travel between distant parts of the cosmos. If technology could one day allow us to travel faster than the speed of light, black holes might provide a passage to uncharted galaxies, opening up a realm of possibilities for space exploration. On the opposite end of the spectrum, some theories challenge the very nature of black holes. Enrico Rinaldi, a scientist based in Tokyo, proposes that black holes might not be physical objects at all but rather holograms. In Rinaldi's view, Black holes could be mirages, visual distortions that appear three-dimensional but lack physical substance. Using quantum matrix models, Rinaldi's team conducted tests based on theories of particles and gravity, proposing that black holes might be projections, operating in a way that's far from the tangible masses we envision. By treating black holes as holograms, researchers can potentially gain a clearer view of their nature and function. The holographic duality and understanding black hole behavior. In an effort to reconcile the different theories about black holes, Rinaldi's team developed a concept known as holographic duality. This model suggests that to understand black holes, scientists should consider the information surrounding them, such as dust and gases, rather than focusing solely on the singularity. Space and time outside the black hole are influenced by what happens within it, meaning that the black hole's gravitational field affects the surrounding environment. This interconnection implies that a black hole's behavior isn't confined to its center but impacts the space around it, continuously growing stronger and consuming nearby matter. The possibility of a moving black hole raises the question of whether one could ever wander close enough to Earth to pose a threat. Conclusion: the future of black hole research. Thanks to recent advancements, scientists are closer than ever to deciphering the mysteries of black holes. Although we now know that the singularity within a black hole is a place where no known form of matter can survive, continued research may unveil pathways to entirely new worlds, or even new galaxies. As researchers explore the strange physics governing these cosmic giants, our understanding of the universe might expand in unprecedented ways. For now, we can only wait to see what future discoveries will reveal. What do you think lies inside black holes? Do you agree with the scientists' theories, or do you have ideas of your own? If you enjoyed this exploration of black holes, be sure to give it a thumbs up and subscribe for more fascinating science videos. See you next time.